So I'm going to change gears. I'm going to go back to academia and hopefully send a message of hope to show you an example of a place that used to be very much pure science and averse to business and risk and commercialization. So we only have 2,200 students and a majority of grad students, only 300 faculty members, okay? Very, very small. 700 postdocs, a lot of Nobel Prize winners, national academies, and our research budget is about 2 to 300 million a year. Occasionally we have snow in the mountains of Pasadena. This is very rare though, it's not the norm. We also run a large laboratory, the NASA Jet Propulsion Laboratory, that's in charge of unmanned exploration of space. You've seen images of the outer planets. That's all coming from that place. So we are a small research-intensive university that also runs a large lab. In terms of invention and intellectual property, Caltech owns all inventions coming out of JPL or the Caltech labs. So for the third year in a row, we got ranked #1 university in the world by Times Higher Education. These rankings mean, I don't know, but you have to take them for a grain of salt, but still, you know, in good companies with the top universities. So to give you an idea of the quality of research that comes out of this place and the disproportionate impact that we have in the world compared to our size. All right, so we're talking about the knowledge economy. I'm going to pass very quickly on this. We think that universities, because they create knowledge and are the prime place where knowledge is created, are poised to play a very important role in the future and the future of the economy. And I'm going to quote Michael Porter, a famous Harvard economist, and who said that universities and specialized research centers are the driving force behind innovation in nearly every region. Although companies and individuals do create a large number of innovations, universities and research centers institutionalize entrepreneurship and ensure a steady flow of new ideas. So that's your key place, universities, that will generate the ideas, and I think we all agree on that. Now, so in the United States, there's been what I call the Big Bang of technology transfer, and that's the Bayh-Dole Act that was passed in 1980. Before that time, a handful of institutions like Stanford, MIT, Wisconsin had found a way to work with, to commercialize invention that were fairly funded. What this law did is that the government is the prime funder of research at top universities. Our example, we're a private university, 95% of our funding comes from the federal government. So what the government said, and this law said, if you get federal funding at a university, you have the ability to retain ownership of the inventions, and you have a mandate to commercialize these inventions. Because before that time, the government was funding a lot of research, owning the inventions, and very few of these inventions actually were commercialized because the government is not really in that business. So they decentralized, give the power to the local universities, and that changed the world of technology transfer. Now at Caltech, most universities started in the 80s, their programs. Caltech waited a long time because we saw ourselves, because the culture was not there, and we were very much pure science. To be clear, this is what I'm talking about when I talk about tech transfer. There's many forms of technology transfer, graduating students from labs and from universities that then go to companies, and that's technology transfer as well. What I'm talking about here is the transfer of ideas coming out of research in the form of intellectual property that then goes out to the private sector through a startup or licensing to a large company. That's what I'm talking about here. And obviously, as universities, we're great at training students, coming up with new ideas, doing research, but we're not good at creating products generally. So you have to have a partner on the other side to help you get those ideas out in the form of products. These are the core things of what TTOs, technology transfer offices, do in the United States. You work with scientists, you get their inventions, you file patents, then you try to license these patents to industry through startups or through large companies. That's the bulk of what you do. And then other activities, but that's really the core thing about tech transfer. So let's go to, let's talk about the models in the United States about technology transfer. So one of the prevalent models, and when I hear my colleague talk about museums, tech transfer, this is what they have generally. So the idea is that when you see inventions that come through the Office of Technology Transfer from the scientists, you are able to evaluate them, look at the ones who are going to be the winners, patent those, focus on those, and then hope for the best. That's what's called the Homerun Model, that you're going to focus on the home runs. The problem with that is that nobody knows what the home runs are going to be. It's impossible to predict, particularly at research universities where what you do is early stage research. And although some discoveries are maybe very neat, open up some new doors, but it's very difficult to foresee ahead of time where these discoveries and inventions will fit in society and products. And so a lot of universities try to predict, to make a selection on that, and then focus all their energies on that. The Kauffman Foundation issued, researchers from the Kauffman Foundation issued this a few years ago that caused a lot of turmoil in the technology transfer world. And they said that instead of focusing on the money and getting financial return on inventions, universities should really follow their mission and be in the business of disseminating these ideas out in the world, getting them out as fast as possible so that they get a chance to actually see the light of day in the commercial sector. Very few of these ideas coming out of universities actually become products. That's just the nature of things, and you have to accept that. So to get a chance of having a few successes, you really need to get large numbers of these inventions out of the laboratories. Another aspect to this is that when you focus on a home run model and you have what you think is a key hit invention, you're really going to be so focused on making sure that you get as much as possible from it that when you actually negotiate with the outside world, industry, companies, startups, you're going to try to get as much as possible out of the deal. And oftentimes, without understanding what's required to commercialize it. And these many, many times will kill a deal with either a VC or a company that's interested in getting the technology out. So this is the mission of our Office of Technology Transfer at Caltech that was created in 1995, very late compared to our colleagues. And really, it's about getting the technology out for the benefit of the public, because most of what we do, most of the research we do is federally funded, so there has to be a return to society. So it's not about the money. Although my boss always asks how much money we bring this year, so that's his problem. Our model is fairly simple and maybe not very intuitive sometimes, some people, but the first one is, so what you need to do as a tech transfer office is establish really close relationships with your faculty. Faculty is a general term. I include students, I include all the research personnel. So that allows you to, that takes time, first of all. That takes the ability of your people to relate to scientists, to understand what they're doing, and gain their trust. Getting the trust of the faculty member at a top university is not easy. They're used to dealing with top-level people. They don't have time, they don't have patience, so you have to really go in there, do your job in a very competent manner, help them remove obstacles, and then get out of the way. So that's the job. And if you're able to do that, you may develop relationships with the faculty that are trusting. If they trust you, they will disclose inventions to you more readily and be involved in the whole process. This process is a very difficult one. As I mentioned, very few ideas make it to the marketplace, so you have to really have researchers behind it. And the role of the faculty, student, inventor in this process is very important from start to finish. They help you with understanding the invention, understanding if it's worth patenting or not, understanding what companies may be the ones that would take the inventions as for a license, whether they want to start a company. All these, so they're involved throughout the whole process of from beginning to finish. And if they're going to start a company, if you want to start a company based on these technologies, you have to have a driver that's from the research side that is very motivated and very persistent. Otherwise, there's so many difficulties and so many obstacles that it will die before it gets a chance. So trusting relationships, faculty is the top thing. If there's one thing to remember from this, from my experience, is that. The second thing, as I mentioned earlier, I don't have a crystal ball, and I don't know many people who have one, so it's impossible to predict the inventions that will be successful. So don't spend a lot of time evaluating these inventions, because first of all, you're going to be wrong most of the time. And second, you may spend a lot of time and money for nothing. So instead, use common sense, talk to your inventors, try to understand how excited they are about the idea and how disruptive potentially it could be. But you can do that in an hour. You don't need to spend 6 months hiring companies to evaluate the commercial viability, research studies, etc. By definition, what you're doing at top universities is ahead of its time. So if you hire a traditional research person, they're going to come back with what the market wants now, or what it wanted probably 5 years ago, because they're always behind, not what it'll need 10 years from now. So limited evaluation. Instead of spending your time evaluating, just cover these inventions through patenting, because if they're good ideas, there's a chance that in the future the market will pick them up, but at least protect them early. And the other aspect is that you can, so a lot of universities do what's called non-confidential summaries of inventions. They send them to 100 companies and then try to see if there's any takers. Well, most people in this field agree that this doesn't work. Again, early stage inventions, companies want things that are much more downstream, much more developed, with prototypes, proof of concept, etc., and they're not going to take a license otherwise. So doing this kind of marketing generally doesn't work. So instead, what we do, we focus on creating startups, because startups, by definition, so you have more of an impact because you can bring people together, get them excited, entrepreneurs, venture capitalists, the inventors, get a team together and try to get the technology to a point where then a large company would be interested. Or if you can grow the company even more, then get an IPO, etc. So, and that's also is very exciting to students and faculty, because you create something new, you're in charge, it's your baby, and you take it as far as you can. Other aspects of our model, very important, is that consistent with the volume idea, we want to be getting these technologies out. So we're going to be very friendly and reasonable when we negotiate with industry. We don't know, for the most part, when we negotiate with a company, whether a startup or a large company, what their business model is. Or they're going to tell us, we're going to ask them, particularly with large companies, when you do a license, they're not going to reveal to you their secrets about their business and margins, etc. So you are kind of at a disadvantage. But nonetheless, you have to make it to understand that what you sell them is not a product, it's an idea, maybe with some IP, that will take lots of time, lots of money to get to a product. So that value initially, there's value, but it's not the whole value. Actually, it's a small part of the entire chain. And a lot of faculty members sometimes underestimate that, and our job is to bring expectations down and help them understand that the idea is not just everything, and there's a lot of stuff that happens after that that's very important. And so the value, you should not overestimate it from the, and you should try to make the negotiation very easy, streamlined, remove obstacles, bureaucracies, etc. And so in our office, every associate has the ability to negotiate from A to Z a license without having to go to me for approval for the business terms, etc. Without having to go to the general counsel for reviews. We can do that in the office. So when you come to us to negotiate, you know that you can get a deal, and the person again across the table from you can actually close a deal. And that's very important for the outside world. There's many universities where it takes 6, 8, 9 a year to get a license, and for most companies that doesn't work, so they just walk away. Finally, this idea of making the person you're going to negotiate with a startup or large company happy is very important, because in the US, and I recognize this is mostly a US thing, but philanthropy is the largest revenue for universities. So raising money from donors is always much more important than raising money through licensing. If you look at throughout the United States, how much money is raised through philanthropy versus licensing, well, the philanthropic aspect is 100 times bigger than licensing stuff. So you have to remember the big picture. The big picture is that if you create happy entrepreneurs that become rich, then they'll go give back to the university if they were happy and if they feel you help them in building their business. I'm going to go back to Kaufman. So they had this interesting study. What I'd like to point out is that there's three things that they regard as important for universities in the commercialization area. The first one is that you have to get a lot of patents because it means that you have a lot of ideas and they're protected, and then so investors may be interested in you. The second one is that these universities are in the business of inventing businesses, starting companies, and that's a key aspect as well. And the third one that's sort of maybe not recognized or underestimated is that the top management at these universities understand that the commercialization, tech transfer aspect at universities is not the core activity that the university does. And the way it's done is very different from other activities. It's much faster, you have to move quick, you have to work like an entrepreneur, like a startup, and most of the academic activities are on a different rhythm, a different cycle. So they don't mess with it. They let the people in the offices do their job and give them the power to do it without outside of the main university bureaucracy, and that's very important. And at many of, maybe in California, the UC system, for example, there are so many rules and regulations, et cetera, that it makes it very difficult for the offices to do their job, and that kills a lot of the deals. So let's look at some metrics to show you what we like to measure. In our world, these are the things that are generally measured. I'm just going to go through a few and show you what happened at Caltech. So in 1995, there was the creation of this office against a lot of faculty recommendation. However, at that time, they said, okay, we're going to not stand in the way, we're going to do it and see what happens. And the provost thought, okay, I have to do this because I have students and younger faculty members who actually want to get involved. So I'm going to start an office, I'm going to do it for 2 years, I'm going to call it an experiment. After 2 years, it will fail, and then we'll close it down and it's over. The office was started with a person, a very entrepreneurial person who was at MIT and BU before, and with the model that I stated earlier. And what he did is the first year he went and met with every faculty member, one after the other, explained what he was there to do. He didn't have horns, or he was not the devil. And he was just have to help them if they needed help in that area. And that building on one-on-one relationships completely changed the face of Caltech in terms of the culture. And you can see that in just a few years, the number of invention disclosures shot up dramatically from 95, like around 60, 70 inventions, to now over 300. And that's on the same basis, the same number of faculty members, same research dollars. And so we weren't getting the inventions out of the faculty because they didn't trust the office. There was no office. There was a patent attorney that was receiving invention disclosure. Issued patents, we went from a very low number to now always in the top 3 or 4 in the United States. And again, that's, you have to remember our size, where we're like 1/4 MIT, we're 1/7 Stanford, 1/10 most of the large universities. So we are very small. However, we produce more patents per faculty than any university by a long shot. This shows you licenses, that we do 40 to 60 licenses per year now. and a large number of startups. Revenues have also gone up and down. This is always, if we have a little time, I'll show you some slides about revenues. But in the tech transfer world, it's very common that, or it's always the case that for the successful universities in terms of making money, 80% or more of the revenues come from one or two inventions. Just the nature of the thing. So it's a hits-driven business. It's not really a business, if you think about it. If you're lucky, you can get one or two things that will hit, but most will fail in terms of generating royalties. Doesn't mean they fail in terms of getting to the market, because you may do a royalty-free deal where you get equity and then you get a return from the equity in the company. But from getting a royalty on a product, it's very difficult. Because again, early stage research and the initial invention often is developed and morphed and transformed over the process of being commercialized in such a way that then when it gets to a product, it's outside the initial patent, so you don't get a royalty. So it's very difficult to get royalties. And most of the very successful financially universities have one drug that has hit a molecule, and they have maybe $100 million of revenue through royalties, but it's very rare. Interesting aspect of this business, and that's very key for tech transfer personnel to understand, is that at a research university, not all faculty members are going to be involved in technology transfer, inventions, etc. At Caltech, you can see that 5% of the faculty account for half of all inventions, okay? And 90% come from 20% of the faculty. So you have your top people who are so overproductive. They're the ones that are really the engine of invention. And the others either are in fields that are not, astronomy maybe, or theoretical physics that are not conducive to inventions that are commercializable, or that are just not interested in the process. And that's fine, okay? The idea is to provide all services and help to the ones who are interested and encourage them and foster their involvement in invention. In our 17, 18 years life, actually this is up to 2012, we've done about 8 companies per year, every year. When we talk about companies, there are companies who have raised at least $500,000, often a lot more. Our companies are based on 10, 15, 20 years of research on heavy intellectual property. There's always a large patent portfolio associated with it. We're not doing things that are like software or apps or things that are close to market. Generally, that's not what we do. That's just the nature of our place. So as a result, you see that they've raised a lot over $4 billion in capital. And again, for our size, 8 companies per year is pretty remarkable, and particularly when you understand where we're located in this ecosystem. We're not in Silicon Valley, we're not in Boston, we're in an area that's not really a hotbed of entrepreneurship. Some results on these companies. So if you look at those 156 companies, 55% are still active companies, employ people, do business, try to make it big. Maybe some of them will. Roughly almost 20% of these companies have been acquired or had an IPO, and they're the ones that fail. And that's pretty high hit rate for a VC that gets these numbers, makes a lot of money. So is our system working? There's a lot of outside sources that make judgments of technology, how that work, efficiency, do we do our job well? So this PwC study shows in one axis, in the x-axis, the efficiency of the office, how well they use their resources, how much money they spend, number of people they have in the office versus how much money they make. And as you can see, we're pretty well positioned in the top right corner. We have a lot of patents. Actually, in the LA area, they moved now, but Northrop Grumman is an aerospace giant, huge company, and we have more patents per year than they have. To tell you how aggressive we are in business. And UCLA, for example, 45 patents per year at that time. They're I don't know, 30 times bigger than us. They have thousands of faculty and many schools, many different. We don't have a school of business. We don't have a school of medicine. We don't have a law school. We're solely science and engineering. Different indexes the Milken Institute put together in terms of commercialization of biotechnology. And this is another index. So all these rankings are, you have to take them with a grain of salt because they use methodologies that are very imprecise, et cetera. But it gives you an indication of how you do your job. And this is supposed to assess effectiveness and efficiency of technology transfer, and this is how they define it. And so I have to say it helps to be small because the denominator is small and it helps the whole number, but that's part of what it is. And so with that, I'll take any questions.
Thank you very much, Fred.